Yes, good morning. The topic what we are going to take here is what I'm going to give you is bilinear transformation. The another name. So the other name of bilinear transformation is Mobius transformation. Okay. So I plan to take four problems here, two problems in bilinear transformation, and two definition we have, which usually we used to ask that in 4 marks. So only the main thing I'm going to cover now. So be careful. So listen here. So bilinear transformation or Mobius transformation. So in Mobius transformation, uh, already I taught you many transformation to you like magnification and what is it? Translation, inversion, reflection. Okay. So in spite of all transformation, this is more important, and always we used to apply this bilinear transformation. Okay, in order to find the function, analytic function, we used to find. Provided whenever we have points of Z plane, I mean that each and every point we have no Z1, Z2, Z3 like that. So certain points of Z plane we have, certain points of W plane we have in our hand, so that we can find the function f of Z acts between this plane and domain and codomain, this plane and that plane. Okay. So that is the thing we are going to see here. We want, I'll add here. So this is the transformation one minute. I'll say the transformation W equal to AZ plus B plus EZ plus D. Say for example, W is equal to 1 by Z means reflection. Like W equal to AZ plus B plus EZ plus D means bilinear transformation. Remember always where A, B, C, D are complex constants as you know. So this is nothing but inverse. Okay, inverse bilinear transformation in which for your syllabus, I think we have certain problems. For your case, they won't ask these things. You don't have your syllabus even. Only this part is important. Okay, I'll go for the problem straight away. See here, first problem. Find bilinear transformation which maps Z points. See, look at the thing. Z points they have given. How many points? 1, 2, 3 points given. Corresponding. As I said, mapping means that is a general thing. For each and every point, corresponding point you will have, isn't it? So Z equal to 0, 1, comma infinity we have in the Z plane, and W is equal to I minus 1 minus I comma we have in the which plane? W plane. Yes. So this is it. I have to find the bilinear transformation. I mean, this transformation I have to find what they have given. Points on Z plane they have given. Points on W plane they have given. Like Z plane, W plane they have given. Z points is like somewhere 0 means I think now you know x0, x plus iy equal to 0 means x0, y also 0 like that. Okay. Say for example, I'll give Z1 here. I mean, Z1 is this one. Z2 is 1, Z3 is infinity, Z1, Z2, Z3 exists here, okay. And then this is nothing but W points like W1, W2, W3 exist in W plane. Now they have given this thing, then what function acts between this and this? Analytic function acts between this plane to that plane. Mean, object you have here, any object on Z plane, in the respect to W plane will find the image of this object. So this is the concept of mapping, as everyone knows. Okay. So this is the case. Now we are going to find this f of Z. Okay. This point only they have given. I mean corresponding the W points or the points also they have been given here. Okay, wait. We'll go for the problem solution. So whenever we go for the solution, whenever bilinear transformation they have asked, you keep on remembering the property. Okay, the assumption we have. Based on that only we can go for the problem. Okay, I'll write the property. I don't know how you will remember, but it's very, very important. One more thing I'll add. This bilinear transformation carry 12 marks. If you're a university paper, definitely they'll ask this question. Okay, or at least, I mean, definitely they'll ask 12 mark in this bilinear transformation. If I solve, nothing is there, you yourself will realize that. I'll write the property as first, W minus W1 into W2 minus W3 divided by W1 minus W2, W3 minus W. Okay. So LHS. Similarly, RHS, if you see, same thing you copy wherever W comes, Z. Z minus Z1, Z2 minus Z3 divided by Z1 minus, yes, Z1 minus Z2 into Z3 minus Z. Okay. So this is the property of your bilinear transformation. For solving, for finding this f of z, I have to apply this, always remember. Okay, mere substitution only, nothing is there, but you just keep on watching how I'm solving. Straight away, you should not substitute. Whenever infinity comes, please be careful. You have to take the variable out, then only you have to substitute. Without that, if you do directly, if you substitute infinity, I never give marks. So just listen what I'm doing here. So W minus W1. What is W1? So this is W1, this is W2, and this is W3. 3 points A means corresponding 3 points here. Okay. So W1 I into W2 minus W3 minus, this is 1, this is I. Please see carefully. So minus 1 plus minus 1 only, right? Yes, minus 1 plus I. Okay, numerator over. Coming to the denominator, come on. So what is the denominator? W1 minus W2. So I plus 1 into what? W3 minus W minus I, W3 minus I minus W, isn't it? So corresponding to that RHS, Z points, let us wait and watch. So Z minus, what is Z1? 0. Z2 minus Z3, where is it, ma? Z2 minus, wait. Z2 minus Z3 we have. So I told you to be careful. Z2, no problem, I can substitute. But what about Z3? It is infinity. So what you are doing, you know, Z1 substitute as, Z2 substitute as 1 minus Z3, write it as it is as Z3. So denominator, once again, Z1 minus Z2. Z1 minus Z2, where it is Z1 minus Z2. So 0 minus 1. And then Z3 minus Z, where is it? Once again, Z3 I'm getting here. I should not substitute directly as infinity. So write Z3 minus of Z. Okay, this is Z, not 2. Okay. So the next step. So what we have to do here? Okay, I'll take minus out. So I'll get my W minus I into minus 1 plus I. W2 is 1 only, right? Yes, minus 1 plus I. So minus 1 plus I. So divided by, here I'll take minus out. So I plus 1 into, what I'll get? I plus W here, isn't it? So coming to here, Z I'll have in the numerator. Here, as I said, I'm going to take minus Z3 out. Okay. So wait and watch. So minus Z3, if I take it out, I'll get 1 minus 1 by Z3, isn't it? In the numerator. Corresponding denominator minus 1. Why can't I cancel this minus? No. Okay. In the next step, I'll cancel. So minus, I'll take it here so because 0 minus 1 is going to be minus 1. Here, I'll take Z3 out. So Z3, if I take it out, 1 minus Z by Z3. So look carefully, Z3 cancel. Now apply, substitute Z3 as infinity. Followed, always you should follow only this step. If you don't follow, I won't give marks. So be careful since it carried 12 marks. Okay. So Z3 get cancelled, right? So 1 by infinity, 0. 1 by infinity, 0. At last, what I'll get only Z, it seems here. Okay. So I'll get only Z. Here, I have to do something. Okay. Why can't I take conjugate of I plus 1? Shall we and try? Yes. So I'll take conjugate of, I think here I'll have only Z in RHS. Coming to LHS part, I have W minus I here. Here, once again, I minus 1 I'll write. The denominator, W plus I here. Minus is there. I'll add minus here. And then here, I have I plus 1, isn't it? What is conjugate of I plus 1? See here, I copied same equation over here. Here, in terms of first as W, second as I, right? Now, here, what is the conjugate of I plus 1? I minus 1, isn't it? I'll take I minus 1 conjugate. Whenever denominator I minus 1 means numerator also, what have to do? Numerator also I minus 1. Okay, LHS is this, RHS is nothing but EZ. Followed? Now, look into it. In the next step, what we are going to see, after this step, so here Z is there, here LHS you'll have like this, no? I took conjugate, you remember? You all remember. Now, just multiply it. What I'll get, so W minus I in the numerator. So I minus 1 the whole square. In the textbook, openly I'm saying we can't add all the steps. So whenever we see the question and answer, whenever we correct the answers, so we are very much particular about these steps. You should not tell at last just in the textbook it is like that, okay? So you should follow the steps. So see here, look into it. I minus 1 the whole square. Here what I have to take minus of w plus I, you keep it as it is. Here I plus 1 into I minus 1, which is nothing but I squared minus 1. A plus b, a minus b, a square minus b square, isn't it? RHS Z itself. RHS is what? Z itself. Okay, now here, so w minus I into I minus 1 whole square, I square a minus b whole square minus 2I plus b square. Okay, b square, no, this is I square, a square minus 2ab plus b square. Denominator minus of w plus I into I square is minus 1, isn't it? I'll get minus 2. Shall I add one more thing? I square is minus 1, isn't it? So can I cancel this and this? Equal to z. Can I cancel 2, 2 minus minus? So what I get here? What I get? Like z minus I, yeah. So at last what I will get here? Minus z by I will go this side, right? Z by I think minus is here, yeah. Okay. So w minus I divided by w plus I'll multiply this minus in the numerator. So is equal to, or otherwise minus I is equal to z. Follow? In the next step, that is z by minus I, which is equal to w minus I divided by w plus I. Followed or not? Okay, here I want to add one property so-called componendo and dividendo method. You all remember that? So anyhow, whenever we come to the steps, at last try that also. If not, once you try, you are getting the same step, means you leave. Okay. Say for example, actually speaking, what I have to get, I need in terms of that Z model. You all remember AZ plus B, CZ plus D. I need in terms of that transformation. In such a way, I have to follow. Okay. So anyhow, I'll try componendo dividendo method. You all remember A by B, C by D. A by B equal to C by D. So A plus B divided by A minus B is equal to C plus D divided by C minus D. Same thing I'm going to try here. So Z plus I means already minus I have. So Z plus I, Z minus I I'll get. Next Z minus means minus into minus plus A minus B. Plus I, which is equal to W minus I plus W plus I divided by W minus I minus W minus I. So Z minus I, Z plus I. I think I can't do after this step. Anyhow, I'm trying. So minus I plus I get cancelled to W here. W get cancelled minus 2I. So 2 goes. So at last same thing I'm getting. So no issue. So W is equal to what? W is equal to minus I Z minus I divided by Z plus I. This is my transformation. Once again, if you take conjugate, the process repeats. So always stop till here. We'll give full marks. Okay. So this is your second problem, as I said, in bilinear transformation. Okay. So the question is the same thing. See here, find bilinear transformation, which maps, I need that function f of z, which maps. What are all the points in the w plane, like infinity, I, 0, in the which plane? Z plane. On 2. What are all the points existing in the w plane? So w1 0, w2 I, and w3 is equal to infinity. We have this, isn't it? Okay. So as usual, I told you to remember the first property, the assumption, like w minus w1, w2 minus w3, w1 minus w2, w3 minus w. See here, don't commit any mistake in the formula. Entire problem will be wrong if you commit any single mistake over here. So be careful whenever we correct the papers. Often we used to see these mistakes. Since you know this is important and often it will come, so be careful. Okay, I'll go for the solution. So this is a bilinear transformation. Already I told you, same thing. Same thing, you just change the variable w as z. Okay, see here, w2 is z2, this is z2, z3 is z3. Okay, so first step, write the property, the assumption of bilinear transformation. So we used to call this as cross ratio property. Okay, cross ratio property. Now mere substitution. So what I said, look into the points. Second step, you have to look into the points. This I0 and all, directly I can substitute. Whenever infinity comes, I told you to be careful. So here one infinity I'm having in the Z plane. Here also W3 in W plane also I'm having one infinity point, which means it goes on. Okay, very huge point. It means, okay. Yes, I'll go for the solution. So W minus W1 is 0, and then W2. What is W2? It's I or 1. I'll check once. It's I only. So W2 is I. So I minus W3 is infinity. So what I said, write it as it is. Next to W1 minus W2, 0 minus I, into W3 minus W3, I have to write it as it is, which is equal to Z minus Z1 is infinity, write it as it is, and Z2 minus Z3. So I minus 0, second step in the denominator, is Z1 minus Z2, I have to write it as it is, Z1, Z2, but I can write Z2 the point, since it is I can write it as it is, Z3 minus Z, so 0 minus Z, okay? Yes, the next step, which point I have to take it out, since infinity comes minus W3, I have to take it out, okay? So already I have W, so minus I'm going to take it out, so W3 minus, minus W3 if I take it out, so 1 minus I by W3, right? Denominator. So already minus I have, W3 I have to take it out. Here 1 minus W by W3, isn't it? Yes, RHS. Here I have to take minus Z1 out, isn't it? Minus Z1, 1 minus Z by Z1. So don't forget one I is here, write it I here. Isn't it? Yes or no? We have one I here. Yes, in the next step. So here minus Z I have here. So along with this, I'll take this Z1 out, isn't it? Yes. Z1, if I take it out, 1 minus I by Z1. See here, minus Z I took it here. This Z1 I took it here. So 1 minus of I by Z1. Mere cancelling. What I have to take limit. What to take? What is infinity? Here limit. What is it? W3 to infinity. Here limit is at 1 to infinity. Followed. So substitute 1 by infinity 0, 1 by infinity 0, 1 by infinity 0, 1 by infinity 0. Okay. So 1 minus 0, 1 minus 0, 1 minus 0, 1 minus 0. Finally, what I get, this minus get cancelled. W3 can get cancelled. So here W by I, here minus goes, 1 I is there. Z1 get cancelled. So I have in the numerator, denominator Z. At last, I'll get like W is equal to I squared by Z. So W is equal to minus 1 by Z. So this is your required transformation. Followed? So this is your required transformation. So I think I have to give in terms of Z. So Z means automatically minus 1 by W. So this is the required transformation. Okay. So listen, as I said in this session, I want to cover, I already told you that bilinear transformation, two problems we have covered, and two more problems, as I said in bilinear transformation, like critical points. Okay, I'll say the meaning for critical points and one model. Okay, model problem I'll teach. Similarly, invariant points, I'll say the definition, and then as usual, one model problem. Now, first of all, I'll go for the critical points. Critical points is nothing but, as I said, see here, whenever we have in real function, you might have studied that stationary points. You all remember stationary points in your first semester. Okay, same thing. So over the real function, here complex function. That's it. That is the difference. So critical point means you all remember stationary point. When you will get stationary point, taking first order derivative f dash of x as 0. You all remember? Whenever you substitute equate to 0 means you will get the points x. At what point this f dash of x is getting 0? In the other way, I'll tell you. What do you mean by derivative? As usual, the function moves from one place to other, moving on, moving. At what point the deflection takes place? Deflection. So deflection. So over there only we are getting this derivative, deflection. Okay, at what point we are getting the deflection, which means slope. So we used to find the point. At what point we are getting. Okay or not? So that is going to be our critical points. So here, since it is, what is that? Complex function, instead of x, you will have, what will have? F dash of, come on, tell me, what is it? F dash of Z as 0. That's all. Okay. So this is the physical meaning of this F dash of Z, as I told you. As for the exam is concerned, definitely you may expect question in critical points which carry 4 marks. So this one also you'll immediate point also may expect. I mean possible questions I'm saying. Okay. So which carry 4 marks. Okay or not? I think I'll go for the problem. So whenever critical point asked, so please be remember that slope, deflection. At what point I'll get deflection? I mean the derivative to be 0. Okay. If you make derivative as 0, I'll get that particular point. Okay, I mean the stationary point, or otherwise critical points I'll get. Okay, yes, in which plane? Is that plane, right? Okay, let us go for the problem. The question is this: find the critical points, find the critical points of the transformation of the transformation W is equal to Ez square. Okay, so what did I say? We have to find critical points exist at what point? F dash of Z 0, isn't it? So f dash of Z means I have to differentiate this with respect to Z. F of Z is W, then what's f dash of Z means? Differentiate this. I'll get 2Z as 0, isn't it? Yes or no? So f dash of Z is equal to 2 times of Z equal to 0. Now 2 is not equal to 0, so that Z will be 0. So this is my critical point. Follow? For this, for what function? I mean, not function, for what transformation? For this transformation. Followed or not? For this transformation, this is critical point. Maybe for some other transformation, if they ask, the point may differ, like 1, 2, like that. Okay or not? Yes, I'll go for the invariant points. Okay, invariant points, I have to select one problem. Okay, I'll choose this problem. So find the invariant points of the transformation. Find the invariant points. Invariant points of the transformation what transformation, you know? I mean the bilinear transformation only. W is equal to 2 times Z plus 6 plus Z plus 7. Usually invariant point comes under what invariant points comes under transformation, bilinear transformation. Similarly, this critical points comes under mapping always. But now I'm covering both the thing in the session itself. Anyhow, I'm saying. So you must notice that, no? Always. Anyhow, you should be thorough and you should notice the points. Okay. So invariant comes under bilinear. Critical points comes under mapping. Okay. I'll go for the solution. Invariant points. Yes. So to find the invariant points, always remember step number 1, put W is equal to Z. You just learn. I'll say what is the meaning. I didn't say. I'll say you before that. Whenever they ask you invariant point, don't get confused with critical point and invariant point. Clearly, I told you in the session where we apply, when to apply, what is the physical meaning also I said to you. Okay, so be careful. You should not commit any mistake in the answers. Okay, so invariant point. So, okay. So always you have to substitute whenever invariant point comes, W as Z in your transformation. Okay, followed or not? You have to substitute W as what have to do? Z in your transformation whenever they ask invariant point, right? Now I'll go for the definition. I mean the meaning, physical meaning for this. What is it, you know? Why we are substituting W as Z? Just imagine W as Z means is equal to Z taking cross product. Practically speaking, you say W as Z cross product and what will get? Some points of Z. Okay or not? That is going to be invariant points in terms of Z. Okay. Now, actually speaking, invariant points, I'll read the definition for you and then I'll explain so that it is convenient to understand. I'll read the definition of the invariant points. Listen carefully. If the image of a point under a transformation, so if the image of a point under the transformation is itself, then the point is called fixed point or invariant point. One more name also is given for that. I'll write that. Fixed point or invariant point, isn't it? So if the image of a point under a transformation is itself, okay, then the point is called fixed point, which means as it is, Z plane, W plane. Suppose if you have a point Z1 here, okay, so corresponding, if you go for the W plane, here also you are getting same point Z1. I mean, same point means the value what you have. Z1 1 means here also W1 1. Okay, so Z2 minus 1. Minus 1 means somewhere here only, no? Okay, anyhow, Z2 as minus 1 means corresponding point W2 exists, right? So W2 is also what? Minus 1. Okay, follow the definition. Isn't it? Yes or no? Can you understand the definition? What they try to say here? Okay, that is going to be invariant points. Exactly the point what is in the Z plane, same point exists in W plane means what? We used to call that point as invariant points. Okay or not? Okay, I think I'll go for the problem. So substitute W as practically what I said. I have to substitute W as z. So z substituted to 2z plus 6, denominator z plus 7. So this is what z, right? So z square plus 7z, LHS, RHS, 2z plus 6. So z square, I think subtract it, what I'll get? Minus 5z, isn't it? Minus 2z means. So plus, plus 5z minus 6 equal to 0. Followed or not? So at last, what is the value of z? Z value is minus 6 comma 1. So this is nothing but the invariant points of for this transformation. Okay, minus 6 and 1 are invariant points for this transformation.